Welcome to all. We will continue with friction now. It's the second class. Consider limiting friction. The most important term in the friction chapter. 1 minute. Before I start this one, some statement you have to write. See, class. Simple statement. See, I won't write. Consider a body of weight W resting on a rough surface. See, resting on a rough surface. Rough surface on which the body under consideration is resting. Let us consider the surface to be horizontal. It is not required. It can be anything. Right? So for simplicity, we will consider surface to be horizontal. Okay. Then, since the body has got weight, it will press the surface down. So there will be a normal reaction, R. R is the normal reaction on the body. See, it is a normal reaction on the body under consideration from the surface on which the body is resting. Now, most important term, let us apply a horizontal force P. Actually, horizontal force or inclined force also will do. Simplicity horizontal. Horizontal force P as shown, see, as shown, purpose or intending to move the block. Intending to move the block or to create motion. Okay, horizontal force P as shown. Now, since the surface is rough, as per the sketch here, horizontal force you are applying right side, therefore a frictional force FF will be developed between the two contact surfaces. See, FF. Frictional force will be always in a direction opposite to the direction in which the body tends to move. Here, in case the body moves, it will move to right side here. So frictional force is left side. For this sketch, if you, by chance if your P is this way, friction will be like this. This all will come later. All the statement you write. Now, some important concept. What you have to write is, you start the P with 0. In case P equal to 0, you write here. In case P equal to 0 means we are not applying any force. The body will simply rest on the surface. Simply rest on the surface. That's all. Normal reaction is there. Frictional force also will be 0. Then your frictional force will also be 0. FF will also be 0. No friction. I told earlier, in the last class, all this told. Now, slowly increase P. As we increase P, the tendency of P is to move the block body to right side. So, opposite direction, frictional force FF will develop. As we increase the force P, see, as we increase the force P, frictional force will also be developed. Initially, applied force P may not be sufficient to overcome the friction. So, till the applied force P is within the effort required to move the body will be at rest or equilibrium. And every time frictional force will come. That is, frictional force will be developed. Now, finally a stage will come. See, I told last class, frictional force is a self-adjusting force and only that much frictional force will be developed which is just required to prevent the motion. Now, finally, you should write here, a stage finally, see, finally, a stage will come when you increase the P, a stage will come when the body is on the verge of moving. On the verge of moving. Or you can tell the body is about to move or motion is just impending. Not at moved, it is on the verge of moving. Okay. Then write, when all the statements are over, then you write this stage. See, if you don't write, you are losing. See, this stage, that is when the body is on the verge of moving or about to move, but still not moved, about to move, is called limiting case. Limiting case of friction, of static friction. Static friction. Limiting case of static friction. Then let FF limit, see, FF limit be the frictional force. Frictional force. You put FF limit is the frictional force. This all I told last time. It is the frictional force. FF limit, LIM. LIM. See, if I put more clearly, next time I won't explain LIM, bracket I write, is the frictional force. Even now, the body is in equilibrium, but it is about to move. Now, in case the value of P is further increased, the body will start moving, then static friction case is closed. It will enter other case of dynamic friction. Then also friction will be there, but that friction is called dynamic friction that we are not considering. In our entire course, reason is there, entire course we are concerned only about static. So many questions are there, only about static friction. Only mechanical people, they study that one, static friction. Therefore, when we consider static friction, the body will be in equilibrium from beginning up to it reaches the stage of limiting friction. So, therefore, the basic conditions of static equilibrium, sigma fx equal to 0, sigma fy equal to 0, and if required, not right now, sigma m0 are all applicable. Okay. So, this is all applicable till and including limiting friction, but not when it goes beyond limiting friction. Now, very important statement. It is experimentally found. See, there is no mathematical proof for this one. It is observation. People made tests, they finally decided and derived, or what you can tell is confirmed. It is experimentally found that the limiting frictional force is proportional to the normal reaction. I will explain this one a little more later. Limiting frictional force is proportional to normal reaction. Slowly, one example I will take where you can understand the full concept. When I finish all this basic part, I will take my first example. When I take my example 1, I will explain all this concept very slowly and briefly, not briefly, elaborately I will explain. It is experimentally found that the limiting frictional force is proportional to normal reaction. That is, you can write, that is FF limit is proportional to R. FF limit is proportional to R. Not alpha, it is proportional to R. Or you can tell mathematically, FF limit is a constant, that is, it is called constant of proportionality, a constant, that is constant of proportionality. This everybody knows, constant into normal reaction R. Okay, now write the statement. Okay, I will remove this one now. I want this space. See, everything you are right. Okay. See, this constant of proportionality means FF is R, is called, very important term, coefficient of friction. See, I will explain everything in simple manner, not make complication. I can go to any complication. I can fully confuse, but I won't do it. Friction. Say, most popular symbol is mu. You write here. Mu. Mu is the most popular symbol throughout the world for coefficient of friction mu. Therefore, you can tell frictional force Ff. But remember, only limit is equal to mu, that is coefficient of friction into normal reaction R. This I told yesterday, you have to believe me. Therefore, remember now, this is Ff limit equal to mu into R. Now, very important, see, very important. I will dictate here. Okay. You can write Ff limit equal to mu into R only for the limiting case. Only when the body is on the verge of moving. Before that means what? Before that means initially when I told finally a stage will come when the body will start moving. Before that is from 0 up to there, in between Ff frictional force, Ff developed will be less than Ff limit. Ff limit. This you know it. Ff developed. Because why? Only that much force is developed which is required to prevent it. So Ff limit, Ff developed, Ff actual developed. See, actual developed will be less than Ff limit, and right here Ff actual developed equal to Ff limit when we reach the limiting stage. This is Ff equal to mu into R. Now, one small concept. There is another way of expressing mu. The mu I will discuss it later. Coefficient of friction depends on what? I will tell it later. Okay. Now see. So I told you just now. I just now told you what? Ff limit. F suffix F. Okay, no problem. We just now concluded you should write systematically Ff limit is mu into normal reaction. Okay. Sorry, NR. I used to long back, 15-20 years earlier, when kilogram was not 20, around 30-40 years earlier, I used to take N. See, natural tendency, I put normal reactions N. Then what happened is, people used to give the question in Newton. If I put 6N, people get confusion. Is it 6 into normal reaction or 6 Newton? From that day onwards, I changed to normal reaction R. R normal. Okay, now, see. Now, correctly, you consider this case once again. See here. Normal reaction is here. Represent normal reaction. This is the normal reaction R. Then, see, this is the frictional force. Graphically, frictional force limit. Now you should consider limit. And this one. So, this one here. Now, see, R is a reaction. Ff also reaction. Make a note here. R is the normal reaction. Ff is a frictional reaction. Because of these two, there will be a resultant reaction. See, the resultant reaction will be here. This is the resultant reaction R resultant. You don't require R resultant. Resultant reaction R. Now, this angle I will call phi. See, let what? R resultant. These are only for concept. Later you don't require R resultant. B resultant reaction. And phi be angle made by the resultant reaction resultant reaction, very important, with normal reaction, resultant reaction with normal reaction, normal reaction. Now, the phi, what I wrote phi here, is also called angle of friction. Angle of friction. Technical name, angle of friction. Remember, therefore, write here, write 10 times. The angle of friction is the angle made by the resultant reaction with the normal reaction. That is called angle of friction. Now do one thing. See here. Once again here. See. This is R. See, correctly. Once again this sketch. See. This is R. Black color. R is black color item. Same color. See. This is R. Normal reaction R. This is FF limit. See. FF limit. Join this way. If you join this way, no, not that way, join this way. See, you complete this way. Then this is, see, this is your resultant reaction, this one. This is your R resultant. This angle is phi. Angle made by resultant reaction with normal reaction R. Therefore, see here, tan phi equal to, see, this is law of triangle of force or law of parallelogram of force. See, when this is one force, other force, resultant comes this way. This you know in engineering mechanics, first class. So, tan phi equal to, see, tan phi equal to, very important, phi is the angle made by resultant with the normal reaction. When you want tan phi, it is always opposite first. It is FF limit. See, tan phi equal to FF limit by R. FF limit by R, normal reaction. Or you can tell what? FF limit equal to tan phi into normal reaction R. Okay. We little earlier, we wrote FF limit equal to mu into R. Mu into R. Right here. Sufficient. Mu into R. Okay. This side remove now and come to the conclusion. We wrote FF limit equal to mu into R. Therefore, see, all this discussion is for limiting case only. Therefore, continue. Therefore, you can tell FF equal to FF limit equal to tan phi into R or FF limit equal to mu into R. Therefore, mu equal to tan phi. Any color will do. I'll use green color. Mu equal to tan phi. Tan of phi. Tan phi. Or you can tell what? Therefore, or you can tell coefficient of friction is tan of, actually not tan of, it is called tangent of. Tangent, you see, tangent of you write, but mathematically tell tan. Tangent of what? Of angle of friction. Angle of friction. Angle of friction. So, mu equal to tan phi. So, coefficient of friction equal to tangent of angle of friction. Now, one important observation I will tell only once. Every class I cannot tell. Once today's class is over, bit later, we will start marathon class, non-stop examples. See, right here, during plenty of examples or questions we are going to solve later. Maybe number of questions may even touch 100 also. It may touch even 100 also. What we want is everywhere, almost in all questions, almost I told, that is a almost 99%. Almost in all the cases, all the questions, we will be considering limiting friction, limiting static friction, or you can write here, or almost all the questions from now up to end of the chapter, 99% questions will be, the question will be such a way that you have to consider when the body is on the verge of moving. See, that is, for almost all questions, we will be considering the body on the verge of moving. See, it has not yet moved, on the verge of moving means about to move, so still equilibrium is there. So for all these questions, see, you write, we will write, I won't explain once again, R as the normal reaction. Resultant reaction you don't require. R as the normal reaction. Permanently. I will use a black color only. We will use R as the normal reaction. And then FF limit is limiting frictional force. Static, not required now. Limiting frictional force, of course, understood, limiting static frictional force. FF is the limiting static frictional force. Then see, we always want to replace this frictional force FF limit in terms of normal reaction R. We always want to replace the frictional force in terms, we will put frictional force, right? Therefore, see here, therefore, once we write FF limit, remember, this is for all FF limit I told. Once we write FF limit, there itself, we will equate it to mu into normal reaction. So that unknown is only R. Mu into normal reaction, where mu is coefficient of friction. I'll discuss more coefficient of friction. Okay, further I will tell later. Mu is coefficient, which is generally given in all questions throughout the world. Usually throughout the world, when a question is given on friction, they will give you coefficient of friction mu. Okay. Therefore, happily write. I'll show an example for you. Right here. Then, but sometimes instead of coefficient of friction, that is mu, in the question, see, instead of coefficient of friction mu, in the question, what? Angle of friction will be given. Angle of friction will be given. will be given. Angle of friction will be given. That is phi. That is phi. Then immediately find tan phi, which itself is coefficient of friction, that is mu. That's all. Okay, then over. One question over. And sometimes in question we may be asked to find mu, coefficient of friction. They will ask. Usually question is find the force required, but some rare question they will ask you, using this data, find the coefficient of friction. Then what? Mark R and FF limit equal to mu R, and find mu, over. Which is the answer for the question. Okay, then, but sometimes I am telling in a simple way so that all those who are writing examinations are heavily benefited. But sometimes in the question we may be asked to find angle of friction, phi. See, we may be asked to find angle of friction, that is phi. Then initially consider mu only. Initially consider coefficient of friction mu only, and mark what? And mark normal reaction R and FF limit equal to mu into R, normal reaction R, and find mu. Find the value of mu. Then, see, they want what? Phi. Then use the relation what? Mu equal to tan phi, and hence find phi by the relation phi equal to tan inverse of mu. Such a simple concept. Okay, further I can't tell. So this is very important. So remember now, see, now I will tell what to do. See, for example, these are all simple to understand. I am preparing you in a systematic way so that there is no confusion. See, I have decided to reduce the speed now. Very slowly I will tell. Purpose is that you understand each and everything. High level I can go, but I am not going. See, example 1, simple example, not question 1. Suppose given, suppose in question given. See, first of all, remember, all these examples are for limiting friction. I told thousands of times. All these are for limiting friction. Otherwise, you will pay penalty. Limiting friction. See, suppose in question given, coefficient of friction is 0.4. That is, they are telling you what? Mu equal to 0.4. Then, in the sketch, what we will do? We will enter R, right here. We will mark R, and FF limit and FF limit, and there only equate it to mu into r, that is here 0.4 into r. 0.4 into r. So in the sketch what we will do? We will mark r this way, and suppose FF limit comes this way. Imagine, you write here, see, FF limit equal to, you write mu into r, there only write 0.3 into r. This is what I told. Okay. Then, see, second example. Suppose in a question given that angle of friction is 22 degrees. Okay, given. That is, they are telling you angle of friction phi equal to 22 degrees. Then immediately get coefficient of friction mu. How? Mu equal to tan phi. See, mu equal to tan phi equal to tan of 22 degrees. Tan of 22 degrees, or therefore you will get mu equal to tan 22, some random number I given there, just like that, tan 22, 0.4040, 4 decimal, 0.404 equal to 0.404. Then mark normal reaction R, and where friction comes, FF limit, you write equal to mu into R, there you write 0.404 into R. This way we will solve the question. So whether they given coefficient, so therefore in all the questions coming up now, it hardly matters whether they give coefficient of friction or angle of friction. Now, if they give coefficient, usually they give round number, 0.2, 0.3 like that. If they give angle, decimal number, more number will come. Okay, so what? At least 3 decimal, 3 or 4 decimal, will put mu value. And other I won't give example. If they ask you to find mu, you maintain mu r, find mu. If they ask to find phi, still maintain mu r, find mu, then phi, angle of friction, is tan inverse of mu. That you are already knowing it here. Okay. This is the first part. I'll go to second part of today's class. Now, I am going to conclude this class with 2 questions. See, question started. Question 1 and question 2. Class means something I will tell now. See, little more principles I have to tell regarding some principles of friction, or some people call rules or laws of friction. Next class, full board, I will write everything. That I will not dictating, I will write in the board and explain. And some more concepts are there, like minimum force required, what is the etc., or least force required. That all I will tell tomorrow, next class. So today, before concluding, let us consider 2 examples. Simple examples, question 1 and question 2. See, question 1 I gave by words. Question 2 I gave by a sketch. First solve for question 1. Make a note, class. Some more explanation part is pending. I will do it next time. Next class is very critical, where I will discuss more and more concepts. This is what all I told today, just to understand. Okay. A rectangular block of weight 3 kilonewton. See here, rectangular block of weight 3 kilonewton is resting on a rough horizontal surface. See, they told the surface has mu equal to 0.45. See, a rough horizontal surface, coefficient of friction between the contact surfaces is 0.45 mu. Then find the horizontal pushing force. Horizontal pushing force means you can push to right side or left side. It is your choice. In the question, if it is not given, we usually take to right side. But in the question given, find the horizontal pushing force. See, push means this way. When the block is on the verge of moving to right side. So we want this block to move to right side. We want to find what force is required, what pushing force is required, or what pushing force the block is on the verge of moving. So, as usual, from today, I decided statements or I'm dictating. Up to some time I will dictate. Then I will tell usual statement. See, every class I cannot tell. Let R be the normal reaction which is perpendicular to the plane of the surface. Mu FF limit is the limiting frictional force which is equal to mu into R, where mu is called the coefficient of friction. Then see the question, see what is mu given, substitute immediately. First few questions I will tell. Then I will tell people, those who don't understand, that is later. See, a stage will come when I might have told it more than 10, 15, 20 times. Then if they expect me to tell every time, I will tell, don't come to my class. Okay, start. Class. Some statement you have to write. I decided to dictate. You have to write it. If you want to really learn, right here. See, let P be the horizontal force. See, they told horizontal pushing force when the block is on the verge of moving to right side. So let it be P. Okay, we don't know how much P. Weight of body is 3 kilonewton acting down. Let R be normal reaction. See, let R be normal reaction, which is perpendicular to the plane. Then, since the question is to find force when the block is on the verge of moving to right side, frictional force will be to left side. See, it will oppose the motion. Once again, since the block is on the verge of moving, this is the case of limiting friction. So, the limiting frictional force, see, you should write there in the solution, let FF limit be the limiting frictional force which will be in a direction opposite to the motion. Intended motion is to right side, so frictional force is left side, and we know that FF limit is equal to mu into normal reaction R, where mu is called coefficient of friction. In the question given, coefficient is 0.45, so mu R equal to 0.45 into R. All the statement you write. Then I told once again, instead of sigma h and sigma v, friction chapter, I am going for sigma fx, sigma fy. So xx, yy. Now, one more statement right here. If you are writing one more statement, first question, one more statement. Since the body is on the verge of moving, it has still not moved. So it is still in static state. On the verge of moving means still it is at rest. A little more force, it will move. Therefore, still basic conditions of static equilibrium are applicable, namely sigma fx equal to 0 and sigma fy equal to 0. Algebraic sum of the forces components of all the force of the entire force system along x-axis equal to 0 and also along y equal to 0. Okay, then start. First make sigma fx equal to 0. We will take right side positive. See what happens now. Plus P minus 0.45 into R, 0.45 into R, that's all, equal to 0. Call this as equation number 1. No simplification required. Over. Then sigma Fy equal to 0, take upward positive. Then plus R minus 3 equal to 0. Therefore, R equal to 3 kilonewton plus 3 kilonewton plus 3 kilonewton. Okay. Make equation number 2, not 2. Okay. Then substituting 2 in 1, actually that 1 and 2 not required. You get R equal to 3 substituting plus P minus 0.45 into 3 equal to 0. Therefore, the horizontal push required to right side is answer 0.45 into 3. Tomorrow there is more explanation when the force is inclined, etc. So many things I am explaining tomorrow's class. 0.45 into 3 is 1.35 kilonewton. Tomorrow's class very, very important. 1.35 plus. Okay. This is the answer for question number 1. Now, I will solve question number 2. Once again, class statement given in the block of, in the question they told weight is 150 Newton. Okay. 150 Newton. Then, okay. Then they told what? A force, find the angle of friction between the contact surfaces if the block is on the verge of moving due to applied force of 60. Now also P is pushing force only, but this time P is pushing force to left side. Okay. Somebody is applying P 60 Newton. Okay, then they see, then since it is trying to move this way, frictional force will be like this. See, this is the frictional force. Ff equal to mu into normal reaction R. Okay, mu into normal reaction R. Then let R be the normal reaction. And mu you have to find now. Actually, right, they want to find angle of friction. Even though they want to find angle of friction, first find coefficient of friction. So, okay, right here, let R be the normal reaction. Since it is given applied force of 60 Newton is what? Is resulting in, the block is on the verge of moving understood to left side. So frictional force is right side, Ff equal to mu R. What all I told last time, on the verge of moving. Therefore, static equilibrium conditions are still applicable. Sigma Fx 0, sigma Fy 0. Just now I told. What extra I told, write everything. Start. Now, sigma Fx equal to 0. Take right side positive. What you get? Plus mu into R. See, we don't put Ff always. You put whatever is there. You write Ff equal to mu R. Right? One thing forgotten. In the question right here, required to find angle of friction phi. See, angle of friction phi. But we know that let mu be coefficient of friction. Coefficient of friction. Then write what? Phi, tan phi. Oh, no, do one thing. You first find mu. Okay, right here. Then we know that tan phi equal to mu. Therefore, phi equal to tan inverse mu. Okay, write the statement. So, therefore, even though question is to find angle of friction phi, you first find mu only. Okay, start. Plus mu R minus 60 equal to 0. Call this as equation number 1. Plus mu R, see, plus mu R minus 60 equal to 0, equation number 1. Then sigma Fy equal to 0, take upward positive. Plus R minus 150 equal to 0. Therefore, your R will come plus 150 Newton. Okay, call equation number 2. Actually not required. Actually you write substituting. Okay, substitute 2 in 1. Actually somebody will be laughing. You can't call equation 2. You got the value of R. Therefore, substitute this R in equation 1. What you get? You get mu into 150 equal to minus 60 equal to 0. Therefore, you will get mu equal to, take that side, 60 by 150. 60 by 150 is 0.4. Mu equal to 0.4. 0.4. Okay, then answer. Now make a note. In the question, instead of asking angle of friction, if they ask coefficient of friction, question is over, answer is mu equal to 0.4. But in the question, they want angle of friction right here. Next, therefore, we know that, once again write, we know that, what, let phi be angle of friction. Once again write, no problem, angle of friction. Then we know that mu equal to tan phi, or phi equal to tan inverse mu equal to tan inverse of 0.4. Therefore, you get phi equal to, write the answer. Third decimal is sufficient. Just check the camera once. Have I gone beyond the limit? No. Not properly came here. Mu, tan mu equal to, but I am dictating tan inverse of 0.4. 0.4, shift tan inverse, answer. Shift tan inverse 0.4. Degree will do 21.8014 degrees. 21.8014 degrees. Phi equal to 21.8. I forgot. See, so good in remembering. 21 point. What is the answer there? Shift tan inverse 0.4. See, 21.8014. 14 degrees. Here, radian solve will not come. I will tell you later. In some of the structural engineering, you should consider the angle in radians. Separate YouTube class I am uploading. Why sometime in radian, why degrees, I will make clear in separate class, not here. General knowledge. Okay. Question is over. Remember, today's two questions are very simple questions, just to understand all the basic concept. Next class is very powerful. I will solve a question where same question I will tell once push applied, then pull applied, then inclined push applied, inclined pull applied, then what is the least force required to move with angle. So very important concept based question will come in the next class. Next class is very, very critical. Question 1, question 2, I will write question 3, I will write very critical question. Okay. We'll meet tomorrow's class, next class. Thank you.